Assalamualaikum and hi, my name is Izzatul Husna binti Abdul Halim. In this video, I'm going to talk about water reticulation project. Introduction to water reticulation. Water reticulation systems are water distribution networks which have to be collected and then treated before distributed to the consumer. Factors come into account like pipe size, location, future expansion, possible leakage, pressure factors, and access for the fire department. The water moves with the help of energy and must overcome any resistance it encounters when changing elevations. The objectives of this project: first, determine the design flow. Second, propose a water supply reservoir and pipe network. Third, to analyze the residual head for the proposed pipe size. The specification of pipe. The diameter that I choose is 0.2 meters. Roughness coefficient is 130. The material of pipe is high density polyethylene, also known as HDPE. Why do I choose high density polyethylene? It is because of the stiffness, strength, toughness, resistance to chemicals and moisture, ease of forming, and permeability to gas. Students are given proposed layout design. This is the peak flow layout design that I draw, which consists of 5 loops. First, we need to calculate the water demand. Roughly, for one house is 1,360 liters per day. For one kindergarten is 55 liters per day per person. One surau is 55 liters per day per person. So the total water demand is the sum of the water demand for all the 5 loops. In this project, I've calculated the total water demand is 279,740 liters per day, which is equivalent to 3.238 times 10 to the power of negative 3 meter cube per second. Next, for the peak flow is 2.5 times to the total water demand. In this project, I've calculated and got 699,350 liters per day. For the fire flow, Q fire is equals to the fire risk plus total water demand. To choose the fire risk, we can refer to the fire risk table. In this project, I chose class D. After that, we move on to head balance method. For the head balance method, the formulas that you need to know is first, the loss of coefficient, which is K. K is equals to 10.69 times by the length divided by the diameter to the power of 4.87 times by the roughness of coefficient power of 1.852. Second, heat loss, which is HF. HF is equals to 10.69 times by the length divided by the diameter to the power of 4.87 times by the flow rate divided by the roughness of coefficient to the power of 1.852. Third, you need to calculate the correction flow rate. But before that, you need to know delta Q is equals to negative total heat the sum of total H divided by N to the sum of H divided by Q. To calculate the flow rate, there is two conditions, which is the non-joining pipe and the adjoining pipe. This is the head balance method that I've calculated for my project. Move on to the residual head. In order to calculate the residual head is equal to the elevation plan plus by H minus by the top water level. If the residual head is more than 7.6 meters, then it is safe. Finally, we're going to talk about reservoir design. The reservoir design that I propose is made by the material of galvanized zinc. The volume capacity of the design is 201.06 meter cube. The structural height is 20 meters. The tank depth is 4 meters. The tank diameter is 8 meters. We've come to the end of this video. Thanks for watching.